So before we start off with this one, just a couple of key points. I those of you who have done P1 with me, okay, so I'm talking to those who have done P1 with me, and I'm also talking to those who have completed P1, regardless of wherever you've done it, whether you've done it with me, at school, wherever, it doesn't matter. If you've done P1, make sure that you keep on revising P1, okay? Don't wait for a test, don't wait for an exam, don't wait for an announcement from your school, or don't wait for a mock, pre-mock, don't wait for anything, okay? Just make sure that you're revising P1 on the side, because it has a lot of weightage, B, it's very easy to forget everything that you've done, okay? So make sure that you're revising P1, and the best way to revise at this point is to solve yearly past papers, okay? All right, now, so we're going to start off with S1. Now, obviously, we're not just going to straight away start a topic today. First, let's do a bit of an introduction, and let's talk about the syllabus, the thresholds, the weightage, and all that stuff. And then we will start today. Okay? We'll start a chapter today as well. So as you guys know, statistics is paper 5. Okay? Statistics is paper 5 of your A-level math exam. Okay? Normally students give it in, well, it's, I haven't really seen a trend, honestly. Okay, some people do give it in AS, some give it in A2. I personally prefer giving giving S1 in AS. Why? Because then you have both options available in A2. You can give S2 because S1 is a prerequisite of S2, and you can also give M1. M1 has no prerequisite. So let's write down today's date. So basically, if you remember, back in O levels and IGCSE, statistics used to be a chapter. That's it. Statistics used to be a chapter, and inside of statistics, you would have a lot of things. You would have cumulative frequency, histogram, bar chart. You would have mean, median, mode, group data, ungrouped data, all those kind of things. Okay. Now it's a completely different subject. Okay. What does that mean? That means you're going to be doing all of those things and a lot more, and in a lot of detail. Okay, so we're going to be doing everything that we did in O levels, such as probability, mean, median, mode, group data, ungrouped data, histogram, bar chart, cumulative frequency, all of that, but in a lot more detail, and other topics as well, such as permutation, combination, normal distribution, binomial distribution. If you've done it, if you've done S1, then you would know what I'm talking about. If you haven't, then eventually you'll find out. Okay? So throughout all of this, it's very important to keep in mind what statistics is all about. Okay, and what's the reason behind studying statistics? So basically, long story short, the whole idea behind studying statistics is so that we can collect data, make sense of it, and then make an informed decision. That's the whole idea behind statistics. Okay, so when you study statistics, you learn how to select the data, as in where to find relevant data. Okay, and then it's not just selection of data, it's the whole collection part also. Okay, like as in once you've selected where you're going to get your data from, then you also have to decide how you're going to get it from. Are you going to go out on a piece and write it down on a piece of paper? Are you going to collect a lot of interviews? Are you going to go with questionnaires? Are you going to make people fill forms? So all of that is also part of statistics. That is, we decide how to collect the data. Okay, and then once you have a lot of data, that data is useless for as long as you can't organize it so that you can make sense of it. Okay, so once you've collected data, depending on the kind of data, whether it's numerical, whether it's qualitative, quantitative, you decide to organize data. So that means after that, the next step is organization and representation of data. Okay, and under this, we learn how to make histogram, cumulative frequency, bar chart, stem and leaf, all those kind of things. And then once you've done that, once you've decided how you're going to represent the data, then you're in a position to summarize the data. Okay? You can summarize everything that you've done, and that makes it easier for anyone to analyze the data. So once you've summarized, that makes it easier for anyone to analyze the data. Okay, and then once you've done that, what's the next step? The next step is to be able to interpret the data, interpret the analysis, and then after that, the last and perhaps the most important step is to make an informed decision. Okay, so these are all the steps that we go through before we make an informed decision. And remember, ultimately, the whole idea of studying statistics is to be able to make an informed decision. Like, for example, if you guys want to buy a new phone, what do you guys do? Do you just go out there and buy it? Or, like, what's the thought process? What's the journey before buying a new phone? Research. Exactly. And when you research, what do you find? When you, okay, you find information, yes, and you find reviews, yes, exactly. Okay, so reviews are basically a way to summarize the data. Okay, and let's say, for example, you want to go to a university. Again, what are you going to do? You're going to do your research. Okay, you're going to first of all, you're not just going to start researching universities in a random country. First, you're going to decide. First, you're going to shortlist a couple of countries where you plan on going. Okay, and then you're gonna decide what are your variables or what are things that matter to you, such as your budget, how many, what programs they're offering, how many years you have to spend there, and then with the help of that, you will shortlist a couple of universities. Then maybe you will take out their data. Their data could be how well their alumni are doing or what the existing students are saying about that university, and then you will make an informed decision. Okay, so we are doing all of this, not obviously at a very grand level and not very formally, but subconsciously this is something that we're doing day in day out. Okay, so I want you guys to keep this in mind at every topic, at every point in the subject. This is what you should keep in mind, that the whole idea of studying statistics is so that we can make an informed decision. Yeah, exactly. That's what a data analyst do. Yeah, that's true. Okay. All right. So the next thing that we're going to talk about is are the marks, weightage, and the threshold. So do you guys know how many marks P1 is? P1, not S1. 75. That's true. And how many marks is S1? 50 marks. That's correct. So basically, you have 50 marks in total, okay? And you get around 6 to 8 questions, all right? 50 marks in total, 6 to 8 questions, and you have 1 hour and 15 minutes, okay? Now, let me tell you something about S1. In P1, time is not that big of a problem. You have plenty of time, and usually people don't end up complaining about time as far as P1 is concerned. This is what I've experienced. But in S1, time can be a problem. Why? Let me tell you. Obviously, it's avoidable. This is not how it's going to be for everyone, but it can be a problem. Why is that? Number one, you have tables to read. Okay, especially when we're doing normal distribution, you will see that you have a lot of tables to read, which can take a lot of time if you don't have a good grip on it. Again, this can be a problem if you don't fulfill certain conditions. So reading the table can be a problem if you don't have a good grip on it. Number two, there are a lot of calculations. Okay, some super lengthy calculations that you have to do. And that also can be a problem if and only if you don't have a good grip on your calculator. Okay, so my suggestion as far as calculator is concerned is that do not switch a calculator in between. If just use one calculator and make sure that you have a good grip on it. You know where all the buttons are and everything. Do not switch your calculator in the middle of the term. Okay. Yes, you have tables to read. We'll get to that. Okay, we'll get to that. That's a different topic altogether, normal distribution, but we'll get to that. So that's one reason why time can be a problem. And number three, there's a lot of working that you need to do. Okay, there are a lot of lengthy formulas, such as formula for standard deviation, variance. If you've done it already, you would know what I'm not talking about. If you haven't, then you'll find out eventually. Okay, so these are the things that you have to keep in mind. And then let's talk about the weightage. So if you're giving this in AS, yes, I would say it's more difficult than P1. I would say that. If you're giving S1 in AS, then S1 has 40% weightage, okay? And P1 on the other hand obviously has 60% weightage, all right? If you're giving this in A level along with S2 or M1, in that case, 20% will be S1 and the remaining 20% will be S2 or M1 depending on whatever you opt for, and then 30% will be P1 and the remaining 30% will be P3. Okay, let's see if this adds to 100. Yeah, it adds to 100. Now the good news is, although it's difficult, but here's the good news. The good news is that because it doesn't have a lot of weightage, I mean, compared to P1, I have seen students get an A in P1, a high A, okay, not like a borderline a high A, and a C, you can say like a mediocre C or perhaps even a high C in S1, and overall end up with an A. Okay, I've seen this happen. Now, I'm not saying that this is not like your license to chill as far as S1 is concerned, but this is just something to keep in mind, okay? To basically tell you the importance of P1 compared to S1, okay? So S1 is important, but when you compare it to P1, you see that it has less weightage as far as P1 is concerned. Yeah, A and AS. I'm talking about AS only, okay? So just a couple of things to keep in mind, all right? And then let's talk about the threshold. These are things that we're not going to be discussing a lot in between once we start off with the topic. So we're just going to spend as much time as necessary in the beginning. So the threshold is usually higher, okay? So I've done some research and I have the 2023 threshold. So the average of average 2023 threshold, that means including February, March, including May, June, and October, November. You guys want to guess out of 50 what the threshold was? 39, yeah. Good job, Fatma. Did you know this already? Or was that a guess? 39 out of 50. Okay, not 45. That would be insane. 39 out of 50. Okay, which is around just below 80%. 39 divided by 50, 78%. That means you have to score at least 78% in order to end up with an A. I mean, remember, this is the average. This includes all variants. This includes all 3 sessions that we have in a year. And this, by the way, is of 2023. Last year, 2023. And the average threshold of 2022, let's write that down. Again, you guys want to guess that? Okay, I just realized I spelled it incorrectly. Close, Fatma. Again, it's 30. It was 37. 37 out of 50. That is approximately 74%. 37 divided by 50. Yeah, 74%. So keep these things in mind. All right. And then lastly, number 4, some important key points. Achha, how much time? S1 will take around 5 to 6 weeks. And then we'll do past papers. Yearly past papers. We'll be doing topical past papers alongside, of course. And then once we're through with the syllabus, we'll be doing yearly past papers. Okay. So important key points, or you can say a couple of things to keep in mind. I've already mentioned them. Number 1 is that you got to have a good command on your calculator. Very important. Just to give you guys an idea, you know, these are the kind of calculations that you will be doing. 5C3, 0.4 to the power of 3, 0.6 to the power of 2, plus 5C4, 0.4 to the power of 4, 0.6 to the power of 1, plus 5C5, 0.4 to the power of 5, 0.6 to the power of 0. Okay, so these are the kind of calculations that you will be asked to do, just to give you guys a random idea. Okay. And then you have to, okay, so this is something that we didn't pay attention to in O-levels. In O-levels, we didn't do any theory. Like, for example, in O-levels, you didn't need to know why we prefer mean over median, or where median is preferred, or where mode is preferred, and all of that, okay? But in S1, you got to do a lot of theory as well. Okay, so a lot of people compromise on theory. Don't do that. Yes, it may only be like a 1 or 2 mark question, but as you can see, there's not a lot of room for error. Okay, so you got to make sure that you pay attention to the theoretical part as well. In math, you can let go of it. I'm talking about in O level and IGCSE math, you can let go of it, but not at all in AS math, in S1. So, number 2 is that you have to pay attention to understanding of theory. Theory as in, okay, let me write it down. Theory as in to answer questions such as which measure in the sense mean, median, or mode is better, and to be able to compare data. Like for example, you may have a lot of values. This is something I think we can cover today only. Dekho, for trig in P1, we'll look at theory so that we understand the subject. Okay, here we pay attention to theory so that we can answer questions related to it. Okay, in trigonometry, you're not questioned on the theoretical part. We look at the theory, we understand, we go the extra mile and pay attention to it so that we can understand the topic. Okay, here you have to look at it because you will be questioned on it. So then we have the third point, which is you got to know what each symbol represents. Again, you can't be too casual about this. You can't be too casual about not having a good grip on your calculator. You can't be casual about theory. You can't be casual about, oh, I don't really pay attention to the symbols. Again, it's going to cost you marks. Know what each symbol represents. So we will have symbols for standard deviation. We'll have symbols for variance, mean. So you got to make sure what it represents. All right, so this was just an introduction. Okay, now we are going to start. In fact, I'll show you guys a glimpse of the syllabus, and a detailed syllabus, inshallah, will be available to you in the Dropbox folder. I'll share it with you guys, but just to give you guys a glimpse, here it is. Okay, you may be thinking that just 5 topics, that's not a lot. Well, that is true, just 5 topics, but this topic we're going to further divide into 2 probability. We will divide into 2 different categories. Discrete random variables, again, we're going to divide into multiple categories. So it's not just 5 topics, but at the same time, it's not lengthy either. Okay. Okay, so before we start, we're going to start off with our first topic today only, which is measures of central tendency. Let's have your questions. Okay, so there are some questions, and please, whenever you guys are asking questions, share it with everyone. Don't just send it to me so that everyone can see what I'm answering. Sir, AS makes 50% of A level. Does getting a C in AS means it's almost impossible? Okay, dekho, so somebody's asked that if you end up with a C in AS, is it impossible to get A in A levels? I would say yes. I would say it's practically impossible. I mean, it's wishful thinking that you will be able to improve it to an A. B, yes, it's possible, but that means you've left no margin of error for yourself. So I've never seen anyone improve a C to an A. C to a B, yes. B to an A, yes. Very common. But improving a C to an A, that's not possible. Okay, sir, I have not studied a single word. Yeah, that's fine. Okay, that's fine, Kabir. Nothing to worry about. We're going to do everything from scratch. At no point I'll assume that you guys know this already. I will assume that you know concepts from O levels, and in some areas I'll assume that you know concepts from P1. Like, for example, you got to know binomial theorem in P1, and what else? Yeah, if you're doing M1, then I'll expect you to know differentiation, integration. Okay, and everything that you guys have done in O level and IGCSE, that is something I expect you guys to know. Sir, knowledge about permutation from O level add math, we can, yeah, of course you can do that. Ahnaf, sir, as you said, can be completed in 6 weeks. I'm assuming S1 is super easy. Okay, it's not super easy. Let's not get carried away, but it's not lengthy. It's tricky, to get a hold of the concepts, but it's not lengthy. Okay? So don't form your opinion just yet, but do keep it in mind that it's a challenging subject. If I say at this point that it's very easy, there's nothing to worry about, it's all going to be fun and games, I'm afraid that you're not going to bring your A game every day. So it is a challenging subject. Let's call a spade a spade. So don't take it lightly, okay? Don't be too casual about it. Between S1 and M1, which is harder to score? I think they're both at the same level. More or less, they're both at the same level. Yes, Fatma, you have a formula sheet, MF19, which we're going to be using. We're not going to, for S1, we're not going to use all of it. It's just 2 pages that we're going to use of that formula sheet. Okay? Because that's a formula sheet for every component. It has formulas for P1, P3, M1, S1, everything. Okay? All right. So, certain statistics mean was not so good in O levels. Okay, if it was not so good in O levels, then to be completely honest with you, it's only going to get difficult in S1. Okay? It's only going to get difficult in S1. So, let's find out. Okay? Sir, if a student is not intelligent, yeah, of course. If you're not intelligent, but if you're hardworking, then of course you can get an A. In fact, let me tell you, not all intelligent students end up with good grades. Sometimes their own intelligence tends to get the better of them. As a result, they keep on slacking. So it's always the hardworking students that come out on top, as per my experience, not necessarily the intelligent ones. You got to be able to appreciate and value hard work and not just rely on intelligence all the time. Okay, so measures of central tendency. Does this remind you guys of something? Measures of central tendency. We're officially starting, by the way. Yes or no? Measures of central tendency. This is the name of the topic. And that's what I'm asking you. Does it remind you of something? Okay, now the interesting thing is that this topic was in O levels as well, except that we never really called it by its actual name. Yeah, it's mean, median, mode. Okay, it's actually mean, median, mode. So measures of central tendency, that's what mean, median, and mode are. Okay. So what are we going to do in this topic? Let's write that down. Yeah, okay. So as far as notes is concerned, I will be sharing my notes with you guys. So I always encourage students to make notes alongside. Okay. But don't just copy everything word for word. Write down what you feel is important, what you feel you will forget. Okay. And then in the end, as soon as the class ends, I'll upload the notes with you guys. I'll share the notes with you guys. I'll upload all the notes in the shared folder. Okay. The link to which you will find in the description of the WhatsApp group. Okay. So what are we going to do in this? In this, we're going to do mean, which is basically average. All right. We're going to do median. We're going to do mode. Okay. Now, all of this, we are going to revise actually. Okay. Why? Because this is something that we have done in O levels and IGCSE as well. What's new will be variance. This is something that's new for us. Okay. Standard deviation. This is also something that's going to be new for us. Okay. Quartiles. Now, quartiles is something that you do in IGCSE, but sadly you don't do it in O levels. But we're going to be doing it from scratch anyway. Okay. So all these three components, these three, you can say measures, are going to be new for us. Okay. So what are the types of data that we have? Question for you guys. Not every type of data is the same. So can you tell me what are the two types? Okay, grouped and ungrouped. Okay. All right. Now, even before that, you have, yes, quantitative. What's the other? One is quantitative. What's the other? Qualitative. Yes. So basically, there are two types of data. Okay. One is numerical, which is what we call quantitative. That's something that we can quantify. Numerical or quantitative. All right, that's one category. The other would be qualitative. Now, can anyone give me an example of qualitative data? Qualitative, or you can say categorical. So, can anyone give me an example of qualitative data? This is very easy, which is why I didn't ask for an example. But what about this? Very good. Blood group. Okay, so blood group is a good example. Gender, or you can say grade. Okay, now grades are also qualitative. Yes, you have boundaries for each grade, but in itself, grades are qualitative. Okay. Then you have numerical or quantitative data. So mostly we're gonna be working with numerical and quantitative data. Okay, so this can be your height, this can be your age, mass, which we call weight, height, age, weight, etc., etc. Okay, now let's focus on numerical data. Numerical data is further categorized into two. Can you guys tell me what are the two categories in which numerical data is divided into? Yes, discrete or group data. Okay, so basically you have ungrouped, which is called, or we say scattered data. Okay, and we call it discrete also. Okay, scattered or discrete. Now think of it this way. Let's say you're in a class of 10 students, okay, and you're just randomly walking around asking people what they scored in a certain test. Okay, what will that data look like? Let's say the test is out of 20, so you're just walking around randomly asking students how much they scored in their last test, which was out of 20. So let's say somebody scored 18, somebody scored 15, somebody scored 20, somebody scored 10, 11, 0, 12. So what does this look like? This is ungrouped. It's scattered. It's all over the place. These are discrete values, but they're scattered. They're not in a group. They're all over the place, which is why we say that this kind of data is ungrouped or scattered slash discrete. Okay. Then you have group data. Now we always prefer to have data in a group because it makes it easier to understand the data. Okay, compared to when it's in scattered form. And even normally data always starts in a scattered form, in an ungrouped form, and then we organize it. Okay, we organize it so that it's easy for us, like I said, to make informed decisions. So how do we do that? How do we group data? So data can be grouped in multiple ways. Okay, not one, but it can be grouped in multiple ways. So for example, you can group data using discrete values. So what does that look like? Let's see. So let's say you have a table of 2 columns. Just a minute. So let's say you have a table over here. Scattered meaning, scattered meaning not arranged. Okay. And let's say in one column you have x, and in the other column you have its frequency. So x, f. Okay. Let's say the frequency of 0 is 4. Let's say the frequency of 1 is 3. Let's say the frequency of 2 is 7. Let's say the frequency of 3 is 5. Okay, so this is a group data, but it's grouped with discrete values. And there's another name for this. It's also known as, this is something that we have dealt with in O levels and IGCSE. It's also known as a frequency table. It's also known as a frequency table. Okay. And then you have data with class intervals. Okay, so you have data with class intervals. What does that look like? Let's see. This is what it looks like. Let's make some room here. This is what data with class intervals can look like. So let's say in one column, we have time, okay, which is in seconds. And in the column after, we have frequency. So let's say from 0 to 2, the frequency is 3. From 2 to, let's say, 5, the frequency, just a minute. From 2 to 5, let's say the frequency is 2. These are just random values, okay, just to give you guys an idea and just so that you can compare the two categories of data. And let's say from 5 to 7, it's 4, okay? And I think this is enough. Now, these are class intervals. Now, notice something about this class. And when I say class, I mean these intervals. Notice something about these values. Or if you don't notice anything yet, then it'll be easier once I write the next category. So here also you have class intervals, okay? Now compare it with this and tell me the difference that you see. Let's say here also we are measuring time, okay, and here's the frequency. And let's say here the time is starting from 0, lesser than or equal to 2, the frequency is 4, and let's say greater than 3, lesser than or equal to 5, the frequency is 2, greater than 5, lesser than or equal to 8, the frequency is 5. Now, they're both class intervals, yes, but they're different. Acha, wait a minute. Let me change this to 6. Okay. Tell me what the difference is. They're both class intervals, okay? They're both group data, but they're both different. Okay, I'm talking about these two. The signs, okay. Anything else that's different? There's something else also that's different. What is that? They are not linked. Okay, I understand what you mean by linked, but that's not how we describe it. The way that we describe it is that one is continuous, the other is not continuous. Okay, so this is an example of continuous class intervals. Okay, why do we call it continuous? Because where the first class ends, the second begins. So here the first class ends at 2, the second starts at 2. The class ends at 5 and the class after starts at 5. This is not continuous. Okay, and why is this not continuous? Why do we say this is not continuous? Let's see. Because it ends at 2, the first class ends at 2 and the second class starts at 3. The second class ends at 5 and the third class starts at 6. So this is not continuous. Now, there is something that we do, which we're not going to look into right now. We will look into it later on, but there is something that we do to convert this not continuous interval into continuous intervals. Okay, what do we do? That's something we're going to look into later on. It's very easy, not difficult at all. But yeah, it's important that you understand the difference between these two types of group data. Okay, they're both grouped, but they're different. Why? Because one is continuous, the other is not continuous. So this data, this kind of data needs to be treated first before we run our calculations. All right. So how did we exactly know? How did we exactly know what, Fatma? How did we exactly know if it was continuous? Well, you can look at the range. They go here, t ends at 2, and it starts, the next class starts at 2. Ends at 5, the next class starts at 5. Here it ends at 2 and starts at 3. So there is a jump. So whenever there is a jump, it's called not continuous. Okay, when there is no jump, it's continuous. Simple. Okay. Okay, Obed, let me know when you're done having a look so we can move on. Okay, all right. So now let's talk about, again, everything that we are doing so far comes under revision. By the way, this is something that we have in O-level and IGCSE as well. It's just that we don't come across questions like these very often. In fact, we barely come across questions like these, so which is why we don't get to deal with them. Okay, but this actually is officially part of your syllabus. I'm pretty sure you guys know that, but it's not something we pay attention to because it's not tested very often. In fact, it hasn't been tested at all as far as I remember. Okay, so let's talk about mean. Okay, so what is mean? It is the average of all terms. So mean, theoretically, again, theory, very important. It is the average. It is the average of all terms. And now we have a symbol for it. What's the symbol? This is the symbol. X with a bar on top of it. This is the symbol for mean. Okay? So again, remember to pay attention to all the symbols. And here the mean that we're talking about is called arithmetic mean. Again, this is not something that you have to know, but remember mean and arithmetic mean, they both mean the same thing. Why? Because you have another variations of mean also, such as geometric mean, harmonic mean. That's not something we do. Okay? But if the question, let's say, randomly says find the arithmetic mean, then don't get confused. It's the same thing. In fact, I'll just write it down. Also known as arithmetic mean. Okay, because there are more, there are different types of mean as well, which we don't have in our syllabus, so you guys don't have to worry about it. Okay, so how do we calculate mean of grouped and ungrouped data? That's what we're going to look into now. How to calculate mean of grouped and ungrouped data. In fact, wait a minute. So mean, which is x bar. Ungrouped is the easiest. Can anyone tell me how to calculate the mean of ungrouped data?
So arrange them in the order.
Do we really have to do that if we're calculating mean? I mean, it's nice if we do that, but is it really necessary?
Add them and then divide.
Yeah, exactly. Add them and divide by 2. Taha, you're mixing it up with median. That's median. What you're saying is median. So if you're calculating mean, here's what you do. Sum of all terms divided by the number of terms. Okay? Or sigma x over n. Okay, you guys know what this symbol means? You guys know what this means? Yes, this means summation, or as we say, sum of. Okay, summation, yes. Summation x over n. Okay? Achha, things get complicated slightly when you have group data to deal with. Okay, that is when things get slightly complicated. Okay? Now, especially if you have group data with discrete values and you have group data with class interval. Again, remember, so group data can be of discrete values and group data can be in class interval form. Okay, so what do we do when we have discrete values? Let's write that down. If you have discrete values, this is how it works. Summation fx over summation f. Again, we're going to do an example. So when we do an example, you'll see how it works. This is how we calculate the mean. And then when you have class intervals, what do we do when we have class intervals? The formula is the same, but there's something else that we do when we're calculating mean when we have group data in class interval form. Midpoint, good job. Okay, so let me write that down. Note, x is the midpoint when we have class intervals. Okay, midpoint of every class. Let me write that down also. X is the midpoint of every class when we have class intervals. Okay, now we're going to do some theory, which, like I said, is very important. So can you think of when mean can be a misleading measure? Like, for example, can you think of a data set which can affect the mean, which can influence the mean immensely? Think about it. Put some thought into it. For example, all the values are below 10. Yes, exactly. What do we call them? What do we call these extremely great and extremely small values? We call them outliers. Okay? Yes, exactly. So basically, mean can be, this is a long note, which is why I'm typing. Okay, you guys can later copy it down or whatever, make a shorter version of it. So basically, mean can be misleading, okay, if there are extremely large or extremely small values. Okay, so this is an example of where mean can be misleading. Okay, like for example, salaries. For example, salaries, and any other example, or even grades. Okay, or score of an exam. So let's say there was a very easy test. Everybody scored in between 70 and 80%, but there's someone who scored 10%. Now, what will be the impact of mean because of that 10%? It's going to bring it down. Okay? Yes. Enough. Yes, they're the same thing. Just like that, let's say that you have salaries, okay? You have salaries of 10 normal people, working 9 to 5. And then the 11th salary is of, let's say, a CEO of a multinational company. Then if we take the mean of those 11 values, now because of that one value, which obviously is going to be extremely large, it's not going to be a good representation of the data. The mean will actually be a misleading value to interpret that data. Okay, so I hope everyone is understanding what I'm saying. So if you have an extremely large and an extremely small value, mean can be misleading. Okay. Now, when is it useful? Okay, so we've seen when it can be misleading. The question is, when is it useful? It's basically useful when the total value is also of interest. Okay, like for example, total income or total production. So in a data where you're interested in the total value, that is where mean can be useful. Okay. So you may come across a question where it might say that why is mean not a good measure to represent this data? So the answer to that would be because you may have some value that's perhaps extremely large or extremely small in that data set. So that's why mean will not be a good, mean can be misleading. Now, if you have, let's say, extremely large and extremely small values, we've seen that mean can be misleading. But what would be the correct measure of central tendency? What would be the correct measure to interpret that data? It's not mean. We've seen that. What else? Nope, not the mode. Actually, it will be the median. Yes, the median is preferred when you have extremely large and extremely small values. We'll see why in a minute. Acha, sir, I don't understand the last sentence. Okay, so the last sentence says that basically, when would you be interested in finding out mean? You'd be interested in finding out mean, or when would be mean useful? That is when the total value is also of interest. Okay, so why? What is the formula for mean? It's sum of all terms divided by the number of terms, or it's summation fx divided by summation f. So if you're interested in the total, okay, or if the total value is meaningful, that is where mean is also useful. Okay? Does that help? All right. Now, so as far as mean is concerned, this is it. Now we're going to do examples all together. Okay, so we're not going to do separate examples for mean and separate for median. First, we'll do mean, median, mode, and mean, median, mode, and then we're going to do examples together. Okay. So now let's talk about median. Let's see what median is. Yes, mean and average are the same thing. Median. Okay. So what is median? Anyone who can tell me the definition? What is median? Anyone? It's the middle value. Yep, that's correct. Median is basically the middle value. So let's write it down. Median is the middle term, but there's a prerequisite. If you have a lot of values, do we just look at the middle term? Sir, I was once told in statistics, mean cannot be considered average in every data set. Is it true? Okay. I know what you're saying. We'll discuss it. Okay? We don't have that fine details in our syllabus, but I know why you're saying that. Yes, it should be grouped, yes, but it should be arranged. It should be arranged in ascending order. So median is the middle term when the data is arranged. Acha, surprisingly, it doesn't necessarily have to be arranged in ascending order. It could be descending order as well. When the data is arranged in either ascending or even descending order. Okay, I'm not sure if this is the right spelling, but you guys get the point. Okay, now again, we have to find out median when the data is grouped as well as ungrouped. Okay, so just like we have to find out average when the data is grouped and ungrouped, we have to find out median when the data is grouped and ungrouped. So what's the formula for calculating median when we have ungrouped or scattered data? N plus 1 upon 2. That's correct. N plus 1 upon the 2th term. Okay, so basically what we do is we arrange the data in ascending order and then we find the middle term using this formula and then we count that term, and whatever that term is, that's our median. Okay, remember n plus 1 upon 2 does not give us our median, it gives us the median term, the central term. Now we have to go back to our data, identify what that term is, and that term is going to be our median. Okay, and what is n here, where n is the number of terms. Again, so far I don't think that we have done anything new, right? Anything that you guys are hearing for the first time so far? Yes or no? What about group data? Again, if we have group data, then group data can be of two types, one of discrete values and the other of class intervals. Okay, so how do we deal with them? Well, there are separate ways of dealing with them. So if you have group data with discrete values such as a frequency table, in that case the formula that you use is this: summation f plus 1 upon the 2th value, very similar to ungrouped data. Okay, and then what if you have class intervals? Now when we have class intervals, what do? Do we find out the median? This is something that you guys have done in O levels in IGCSE as well. When you have class intervals, does the question say to find the median or does the question say to find something else? Okay, Vasi, what you're saying is correct, but that's for mode. The question says to find the median interval, or the question will say to find the interval in which the median lies, or yes, the question will say to find the median class. Okay, because you can't find the exact median. So if you have class intervals, the question will say to find out the median interval, which means to find out the interval in which the median lies. Now, there is a way to actually find out the exact median as well. So the reason why we can't find out the exact, Fatma, to answer your question, is because what we will do is we will find out the class in which the median lies. So for example, if let's say the median lies in this class, that means it can be 2, it can be anything between 2 and 5. So we can't find out the exact value. Okay, just like if we have group data, we can't find out the exact average. That is when the question will always say to estimate the mean. Why? Because we will be multiplying the frequency by the midpoint. Okay, so chalo, I'm glad you asked me that question. Remember, if you're taking out the average and you're given group data, in group data, the question will always ask you to estimate the mean. Okay, just like that, in group data, we can't find out the exact median, we find the median interval. Now, we can find out the exact median, or we can find out a relatively closer to the actual median. But for that, we have to draw something. What is that? If I wish to find out the exact median, exact, or let's say close to the actual value. Graph. What graph? Elaborate. Cumulative frequency graph. That's correct. So if let's say you're asked to find out the exact median, okay, there will always be a step before, and that is the cumulative frequency graph. Okay, cumulative frequency graph is, or cumulative frequency diagram is to be used to find out the exact median. Okay, now let's write down a couple of important key points regarding median. So when is median useful? Again, something we've discussed already. It is useful, you guys want to complete the sentence? When when is median useful? We've seen the drawback of mean. So how does median stand out? It's like too much to take at a time. Well, welcome to A levels, Fatma. I hope you're not still in your grade 9 or grade 8 mindset. Okay, the difficult the challenge, the difficult the subject, the more effort you have to put in. Okay, a large, yeah, exactly. So it's useful when you have extremely large or extremely small values. Okay, why? Because remember, median is resistant to outliers. Oops. Median is resistant to outliers. Okay, outliers are basically extremely large or extremely small values. For example, salaries. The example that I gave earlier, for example, salaries. So if you have, let's say, a data where you've taken data which contains salaries of, let's say, 10 people, but you know the 10 people are uh, from all categories. Okay, you have CEOs, you have mid-level or beginner, entry level. So in that case, you would prefer to calculate the median. Okay. Yes, exactly. That's why we have median salaries and total populations. Yes. Outliers, Fatma, are basically extremely large and extremely small values. Okay, I mean, think of it. It's something that stands out. That's what you call outliers. Okay, how does that help? You mean to ask that why is median useful in that case? Okay, dekho. If let's say we take the average, okay, if let's say we take the mean, and you have an extremely large value. Let me put it to you this way, chalo. Let's say that there is an extremely difficult test, okay, in which everyone has scored around 60 to 70%. Okay? Difficult test, everyone scored around, let's say 50 to 60%. But let's say there is some genius who has managed to score 100%. Now think about it. Now let's say we're calculating the average score of that class. What will be the impact of that 100% on the mean? Now, what will be, I'm not asking for an exact value, but what will be the impact of that extremely high score on the mean? Let me put it to you this way. Will it increase it or will it decrease it? Will it increase the mean or will it decrease the mean? It will increase it, right? It will increase it. Why? Because when you're calculating mean, you have to consider all the values. Okay? Now let's say we calculate the median. So will that 100% have any impact on the median? Yes or no? Will that 100% have any impact on the median? Median means we're calculating the middle term, the score right at the middle. Will there be an impact? No, because it will be excluded. Now, you know how thresholds work? You know how thresholds are calculated? Okay, let me explain. So basically, once you guys give your exam of whatever subject, then what do the examiners do? They always exclude the students who have extremely high scores, like 100% or 98 or 99%, and they always exclude the students who have extremely low scores. Because if you think about it, there will always be not a whole bunch, but there will always be a considerable number of students who have done extremely well, irrespective of the difficulty level of the test, and there will always be a bunch of students who have done horrible, no, even if the test is, let's say, extremely easy. So what do they do? They exclude them from the data set, and then they look at where the majority of the data lies, and based on those scores, they calculate the median. Okay, they calculate the threshold basically. So that's how threshold works. It's not that they take all the scores into consideration and then divide by the number of students and then set a threshold. No, they look at basically it ruins the exactly, it ruins the consistency, you can say that. Okay, so that if you have extremely large or extremely small values, that is when you prefer median over mean. Okay, because median will not be influenced by extremely large or extremely small values. Okay, what is the second type of class interval? The second type of class interval is when you have not continuous classes. Okay, so this is also class intervals. This also is an example of class intervals. Okay, no. Wait a minute. So basically, in median, you have class intervals only. Okay, but if you're most of the time we will be asked to calculate the median interval. But if let's say you have to calculate the exact median, and you're given data which is in class interval form, so for that we will have to make a cumulative frequency graph. These are not two different categories. Okay, these are not two different types of class interval. So in class intervals there are two possibilities. Maybe the question will ask you to calculate the median interval, or maybe the question will ask you to calculate the exact median, which is when you have to use the cumulative frequency curve. Okay, all right, now let's talk about mode. Mode is perhaps the easiest measure there is. Can anyone tell me what mode is? Most occurring, yes. So mode, yeah, so it's basically the most frequently occurring term or the value with the highest frequency. So I'm unable to understand, you said extremely high and low, better to use the median. Then in your example, just excluded high and low marks to get median. How does that make sense? Okay, देखो. So let me explain that again. Just a minute. Let me write this down, then I'll explain that again. The most frequently occurring So Jannat, the reason why I said that we exclude extreme values is because when threshold is being calculated, that is when average is being used, or that is when mean is used. Okay, so because we're using mean, that is why we exclude extremely large and extremely small values. Okay, why do we do that? Like we saw earlier, because mean can be influenced by extremely high and extremely low values, whereas median cannot be. Okay, so again, why do we exclude extremely high and extremely low values when calculating mean? Because it can be influenced. What about median? No, median cannot be influenced by extremely high and extremely low values. So we can use median. The thing is, median is just one term, but when you're setting grade boundaries, when you're setting threshold boundaries, you need multiple boundaries. So you can't just rely on median. Okay. All right. So the most frequently occurring term when it's ungrouped, or it's the value with the highest frequency when it is grouped but in discrete form. When it is grouped and discrete form, like a frequency table. Okay. And what about when you have class intervals? In that case, what we do is that we look at the interval or the class with the highest frequency. The interval with the highest frequency. This is when you have group data with class intervals. Okay. Now, can you have more than one mean? Yes or no? Can you have more than one mean? No. Can you have more than one median? No. Can you have more than one mode? Yes, you can. Okay, now remember, you can't have more than one mean, you can't have more than one median, but you can have more than one mode. Okay, so remember this note, and that is there can be more than one mode. Okay, that means you can have two modes. Okay, in which case we call it to be bimodal. Bi, as you know, means two, binomial, and bisect. So bimodal means that you have two modes. Okay. Okay. Now, when do you think mode can be useful? Again, theory, important. When do you think? No, you don't have trimodal. You don't have trimodal data sets. When do you think mode can be useful? Finding a trend. That's correct. Okay, so it's useful when the most occurring value is of interest. Like, for example, let's say there's a blood bank. Okay, now normally you have a certain blood group. Again, I don't know which one is the most common, but I think it's B positive. I'm not too sure. But if you have a blood bank, so the way the blood bank would prefer to have blood bag stored is that they would prefer to have the one group that is most common to be of the highest frequency. Okay, they would prefer the blood group that is the most common to be stored the most. Okay, so that's one example. Another example would be that let's say you want to introduce a new design of shoes. Okay, you run a shoes shop and you want to introduce a new design. Now, you're not just going to go out and order every size of that design. You would start by stocking the one size that sells the most. Okay, just like that, if let's say you want to introduce a new design of t-shirts, you're not just going to take that design and order 50 t-shirts of every size. No, you're going to divide it in such a way that you're going to have the one size that sells the most of the highest frequency, and then the next common size, and then the least common size. Okay, are elections an example of mode? Yeah, you can say that. I mean, when we're looking at election results, we're looking at mode. Yeah, you can say the one candidate with the highest number of votes. Yeah, you can say that. Okay, but that's not exactly where mode is seen useful. I mean, this is just common sense that the one with the majority wins. But we're seeing how mode can help us make decisions. So like I said, if let's say you're running a shoe shop or a t-shirt shop and you want to introduce a new design, you're going to start stocking the size that sells the most. Okay? So it's useful when most occurring value is of interest. For example, a new design, and in that case you will start stocking the size that sells the most. Okay, so, and also remember that it's not useful. Remember that it is not useful when the data set is small. Not useful when the data set is small. Okay, so in order for your mode to make sense, you should have large amounts of data. Okay, so any questions so far? If yes, please feel free to ask. So there's no formula as such for mode. Okay, You just have to see the value with the highest frequency or the class interval which has the highest frequency. So I don't understand the first two sentences. Okay, I'll explain. So if you have ungrouped data, in that case, you're going to see the value that's most frequent. Like, for example, let's say you have, in fact, let's go back to this example here. So in this case, what's going to be our mode? What's the one value that occurs the most? In fact, let me just add a value to it. Let's say I add 11. Okay. So this is ungrouped or scattered data. If I want to find out the mode over here, I will see the value which occurs the most, or the most frequently occurring value, which is 11. Okay, so 11 is our mode right here. If you have group data but it's in discrete form, in that case, we're going to look at the value which has the highest frequency. So which value has the highest frequency? 2. So 2 is going to be our mode. If let's say you have class intervals, then you're going to look for the interval with the highest frequency. So here, what's going to be our modal class? It's going to be 5 to 7. Okay, so that's what it means. All right, now let's do an example. Again, all of this, other than the theory, was just a refresher. Okay, we haven't done anything new so far. It was all you can say. It was all revision. Okay, so I've taken out some questions which I'd like you guys to solve. In fact, we're gonna solve them together. And here they are. Can you show the main page? Yeah, sure. Here it is. No, here it is. Let me know when you're done having a look. Bimodal and discrete are the words I'm not aware of. Discrete, okay. What do you think the word discrete means? Forget math and statistics for a minute. Just tell me the meaning of discrete. Unorganized, okay. No. Different, yes. Okay, so discrete basically means when you have whole numbers. Okay, when you have whole numbers like these. So this is an example of discrete values. Okay, and when we say bimodal, bimodal means a data set which has two modes. Bi means two, modal is just another word for mode. Bimodal data set is a data set which has two modes. Like, for example, let's say here I add 10. Okay, so now this data set will be considered bimodal. Why? Because it has two modes. One is 10 and the other is 11. Why? Because both of them occurred twice. Okay, I hope that helps. Acha, so as I was saying, I have some example questions which I would like you guys to solve. Here, we're not going to do all of them, of course. Okay, and remember what I said about lengthy calculations. You guys will get an idea what I meant over here. So it says for each of these sets of data, find the mode, mean, and median. Okay. State with reason which you consider to be the most appropriate form of average to describe the distribution. Okay. Now, earlier I said that mean is average. Okay. But actually, you have three different averages. Okay. What are the three different averages? You have mean, median, and mode. Okay, normally we consider mean, we say mean to be average. Okay, but in statistics, when we say average, it could be the mean, median, or the mode. So that's why this question is saying find which you consider to be the most appropriate form of average. Okay, so these three are basically called, these three come under averages. All right, in O levels and IGCSE we weren't that specific, we would be casual about this, but now remember that mean, median, and mode, there are three different forms of averages. Okay, and mean is not exactly equal to average. All three of them come under average. Okay, so I want you to keep that in mind. Okay, so let's take the first data set. All right, so by the way, this is one data set. Okay, we don't have two different data sets. All of this is one data set. Okay, so let's pick a data set which has fewer values, just so that our calculations become easier. Let's do part 2. So if I want to calculate the mean in part 2, what should I do? Question for you guys. If I want to calculate the mean, in fact, let's start with the mode. Okay, let's see what the mode is going to be for part 2. So that's what the question says, right? It says for each of these data sets, find the mode, mean, and median. So let's start with mode. So can anyone tell me how to calculate the mode? What should I do? Add all the values, divide by 30. ठीक है, सही है. Now, most occurring. So let me just zoom out a little. Okay, so can you eyeball the mode for this question? Mode is 0. Let's see. So we have 0 that's occurring once, twice, 3, 4. 4 times. Let's see if that's the correct answer. Just a minute. Yeah. So the mode for part 2 is 0. Okay. Now if I want to calculate the median. Median is 71. Are you sure about that? You're saying the mode is 71. No, actually the mode is 0. 71 occurs. Let's see how many times 71 occurs. 71 occurs once, twice, thrice. 71 occurs 3 times. 0 on the other hand occurs 4 times. 1, 2, 3, 4. So the mode is 0. Okay. Now, in order to calculate the median, what should I do? Can I just calculate the median the way this data set is? No. What should I do then? I should arrange it. Okay. So if let's arrange it in ascending order. How many values do we have? We have 1, 2, 3, 4, 5, 10, 20, 30. Okay. So we have to arrange these 30 terms in ascending order. Okay, so let's do it. And a good idea would be to cross out the values that you've used. So we can see 0 occurs how many times? 0 occurs 4 times. So let's cross it out. 1, 2, 3, 4. Now, what's the next smallest value after 0? Let's see. We have 39, I believe. Any value that's less than 39? Let's see. 55, 78. Nope, 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 nope. Nope. So it's 39. Okay, then after 39, what's the next smallest value? I think it's 43. Let's see. Yeah, so it's 43, which occurs how many times? It occurs, I think just once. Yeah. And then after 43, what do we have? We have 45. So we have 45 once, we have 45 twice, and I think that's it. Okay, so after 45, what do we have? We have, let's see, any value in 40s? Nope, it's 50s. So I think we have 51. Yeah, 51 once. Do we have any other 51? No, we don't. Okay, so after that, what do we have? We have 52. Do we have 52? Do we have 52? 52, 52. Yeah, here it is. Okay, now what do you guys suggest? Do I need to arrange all these values in ascending order? I mean, do I have to do it till 30? Or can we be smart about it a little? Once we've arranged these values in ascending order, yeah, how about we do it till 16? How will that help? Because ultimately, this is what we're going to do. We're going to take the total number of terms, add 1 to it, and then divide by 2. Okay, so 30 plus 1 is 31. 31 divided by 2 is 15.5. Now, what happens when you're in a situation like this? In this case, what you do is you take the average of the 15th and the 16th term. Okay, you don't take the average of 15, you take the average of the 15th and the 60th term. So that means I'll stop after the 16th term. There's no point in arranging till the 30th term. Okay, so how many terms do we have so far? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so still 6 more terms to go. So 52, I've crossed it out. Now after 52, what do we have? We have 55. Okay, so where's 55? Do I see 55? Yeah, here it is. Okay, 54. 54, 54. Oh, yeah, you're right. We have 54 also. 54 and 55. Okay, so let's cross out 54. Then after 55, we have 56. Okay, so let's cross this out. Do we have any more 56? No, I don't think we do. Yeah, we do actually. We have 56 twice. Yes. Okay. Then let's see how many terms do we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so we have 14 terms. That means we just need 2 more terms. So after 56, what do we have? We have 57. So let's cross that out. After 57, what do we have? Do we have 58? No, we don't have 58. But do we have 59? Yes, we have 59, which occurs twice. Okay. So what do you think the median is going to be? It's going to be the average of the 15th and the 16th term, which means 57 plus 59 divided by 2, which is equal to 58. Okay, I'll explain why we took 16 values. Ultimately, what we're looking for is we're looking for the middle term. Okay, so if you're looking for just the middle term, what's the formula for it? This is the formula. You take the total number of terms, you add 1 to it, you divide by 2. The total number of terms are 30. If I add 1 to it, that's 31, divide by 2. So what we end up with is 15.5. So whenever you're in a situation like this where the term is in decimal, so I can't say look at the 15.5th term. What we have to do over here is we have to say that since 15.5 is in between two terms, 15 and 16, that means we're going to take the average of the 15th and the 16th term. That means it doesn't matter what the 57th term is, 58, 59, all the way to 30, it doesn't matter. So this right here is our median. Okay. Now what about the mode? Oh, sorry, what about the average? So for average, here's what we're going to do. I'll just write down the answer. We're not going to waste a lot of time. What we're going to do is we're going to add all the values, that is 55 plus 78 plus 45 and so on and so forth, all the way to 63. Okay, we're going to add all these values and we're going to divide them by the total number of terms, which is 30. And what we get is we get 52.8. Okay. Now, all of this was revision. Okay, nothing new so far, really. Yes, lengthy questions, but nothing new. Part B. What will be the most appropriate form of average to describe the distribution? So in this case, what would you prefer? Would you prefer mean? Would you prefer mode? Or would you prefer median for part 2? See, that's what I said. क्या बोलते हैं, Ubaidullah, that you will get some lengthy calculations. Yes, in this case, we will prefer median. Acha, why is that? Because it says state with reason. Median is the correct answer to part B. But why would we prefer the median? Yes, because you have extremely small and extremely large values. Okay, median because mean can be influenced by extreme values. Okay. Now, what about the first part? I don't want you guys to calculate the mean, median, and mode for the first part. Okay. But I want you guys to answer for part B for the first part, where you have ages. In this case, what would you prefer? In this case, you would prefer the mean. Why is that? Yes, because the values are close to each other, so you would prefer mean. Okay. Okay. Yes, exactly. So it's important to understand when mean is preferred and when median is preferred. Okay, mode is something else altogether, but it's very important to understand when to prefer median over mean. Okay, so everything that we have done so far was just a revision of something that you have done already in O levels, added with a lot of theory. Okay. So what we're going to do in the next class, inshallah, is we're going to learn, not learn again, we're going to learn how to revise. We're going to revise how to calculate the mean, median, and mode of group data, and group data with frequency table, group data with class interval. We're going to see what happens if you have a class interval which is not continuous, what do we do in order to make it continuous. And then we will start quartiles, and if time allows, we'll start variance and standard deviation also. Okay, so from variance and onwards, what we will do will be new for all of you. Okay, then from that point onwards, you won't have anything that you would have done in math. Okay, so take care everyone once again. Allah Hafiz.